So let's have a look at the path of the outflows from the Aegean seas. Okay, we talked about Mediterranean seas. And what you actually get is, because of a density difference across the sills that you have to the west, on both sides of Iceland, you get density-driven overflow. And the pathways and the volume transport is indicated in this sketch. The main outflow happens across the Denmark Strait. Denmark Strait is shown here. It's this green curve. And the units that are shown here are the volume transport in Sverdrups. Okay, you have a 2 million cubic meters per second overflow or outflow near the bottom from the Greenland Sea into the ambient North Atlantic. You have a one Sverdrup coming here. There are two branches. You essentially get two Sverdrups coming here on this side. Okay? And then what happens along the pathway of this, these flows actually become stronger as they go, and they actually entrain, bring in volume of ambient water. So at the end, what feeds into the deep western boundary currents is actually ends up with 10, 15 Sverdrups at the end. Okay, in addition to that comes the flow that is created, the outflow from the Labrador Sea. That's something. Okay, so let's have a look at how does it now look in detail. So if you go and measure the outflow in Denmark Strait, and we actually do have measurements, direct measurements from the Denmark Strait, and let's see how that looks like. Next slide, here is some measurements of the temperature field if you cut across the Denmark Strait. Okay, and you can see in the terms of structure of that, there is a flow of water. And in this region, it's 2 degrees cold. It's the coldest water here. It sits on one side of the Denmark Strait. And you essentially cut through the flow of this cold water, which runs into the North Pacific. It's only a few hundred meters thick and on a distance of 60 kilometers, but it runs all the time. And this is actually the seeping outflow of dense water from the Aegean seas that starts driving the deep circulation. It's one of the drivers. Okay, so you might ask the question is, why does the outflow happen on one side? Okay, and it actually happens on one side because of the Coriolis force. Because of the Coriolis force, and you actually look into the Greenland Sea on this in this plot. So if you looked from the Greenland Sea into the North Atlantic, okay, you have to flip this figure around. The outflow is actually moved over to the right-hand side of the strait. If you look into the direction, and this is what you can see here. Okay, this is the outflow for the region. It's pretty special to have observations like this. It's lots of fun actually going on a research vessel and doing these observations. Anyway, so this is fairly old, from 1969, and that's before most of you were born. All right.